to Joe Bremen, who is your presenter today. Joe?
Hello, and welcome to today's Introduction to ArcGIS Data Models live training seminar. My name is Joe Bremen, and I work in professional services on the Enterprise Technical Strategies team. We're presenting to you from ESRI in Redlands, California. With me today is Brenda Simmons. Brenda is an instructor with Educational Services and will help me to handle your questions today. The ESRI approach to creating data models involves forming collaborations with GIS industry leads and working together with them to produce data model design templates and case studies that build on ideas common to each area of focus. The topics covered in the next hour are divided into two sections: data model concepts and their implementation. Each topic is followed by a demonstration of the related software application and specific functionality that is most useful to people interested in data modeling and implementation in ArcGIS. We will also have a question and answer session in the middle of the hour and again at the end. The first topic we will cover is related to data model concepts. There are some specific tools that are used to create databases from models. But before we get into some of the examples of this, let's identify more clearly what is a data model. The data models that ESRI works to create are practical templates for implementing a GIS project. They serve as a good starting point to help you to create a geodatabase, or you can use them as a reference in refining your own data model. When multiple people or organizations use the same data model, the resulting databases have similar feature names and attributes, providing for easier interoperability. A good data model design can be key to making better decisions based on available data or geographic information, while supporting existing standards. The data modeling cycle can be divided into phases that have an iterative workflow. We'll often move from the real-world objects or elements, the subjects of data capture, to a conceptual model. This is usually a diagram composed of the relevant features and objects. We identify the most useful relationships or refined elements to the UML model, or Unified Modeling Language format. This is called the logical model. And then from that, we can create a physical geodatabase. This can be a personal geodatabase or an enterprise geodatabase. We do this using computer-aided software engineering tools or case tools. There's often a cyclical or iterative process involved to create the physical geodatabase. A lot of times we'll test a prototype database and see things that we want to go back and change in the logical model, leading to a recreation of the database. It's okay if you aren't familiar with all these terms. We're going to be showing you some of the best ways to work with the data model templates using tools in ArcGIS later on in the demo. Let's take a minute to ask a question and take a poll of the audience today. If you want to participate, click the Review Question link in the upper left corner of your web browser. You may also use this control at any time to submit a question, which we'll try to answer in the upcoming question and answer sessions. Just click the Ask the Presenter link. So, our question is this: which of the following ESRI data types do you most commonly use? Coverage, Shapefile, or a geodatabase feature class? Just click your answer in your browser control, and we'll review the answers and your responses in a few minutes. Whether you're working with shapefiles, coverages, or feature classes in the geodatabase, identifying the thematic groupings of the GIS layer stack is a useful initial step towards giving names to the common elements that will be most important in the database. The layer stack is a representation of all the elements that are relevant to the GIS datasets. It's often one of the first things that we'll create as a result of the collaborations we have with many different people and organizations to assess the most useful layers that will be part of the GIS analysis. Here we're looking at a layer stack for a parcels data model that includes an orthophoto, the parcels framework, ownership and tax parcels, site addresses and use and restrictions, rights and interests, and administrative areas. These are all of the layers in the conceptual model which are going to be important in creating the geodatabase. Once the key layers have been identified, their physical representation in the GIS is often based on the information requirements. For example, a marine data model will often start with a layer of bathymetry representing the ocean floor. This layer can be created by the interpolation of points, in this case soundings, which can also be added or draped onto the seafloor. The interpolation of points depends on the elevation or depth value being stored in the attribute table. So creating points and their detailed attribute information becomes a key modeling consideration. Contour lines may also be used to show depth and can be generated as a graphic element or stored as a feature in the database. A more complex set of point measurements may reside in the water column, representing data gathered at a specific time and depth. A relationship between these point features and a time attribute table can help to perform query and analysis on this data to create new information. And then there's a sea surface layer to represent the ocean surface. This simple representation of the marine data model shows some of the layers used and the modeling considerations that are included in the design process. As I described the layer stack before in the conceptual model, we can see here how the physical representation of the GIS layers is important to identify early on in the project. Okay, we've received a lot of replies from the group, and it's interesting to see that there's about 5% of the audience working with coverage data. A large percentage, perhaps over 60%, are working with Shapefile data, and about 35% of you are working currently with Geodatabase feature class data. Now we've described the data modeling cycle as iterative. With that in mind, there are a set of 10 steps that you can use as a guideline to the modeling process of designing the geodatabase. These steps are divided into the 3 phases that we've mentioned: the conceptual, logical, and physical design. The first of the conceptual steps is to identify the information products. Are you creating a globe to represent geographic data? Or maybe an IMS site to serve map across the internet? Identifying the information goals of your GIS will help to steer some of the modeling decisions that you will make along the way. In step 2, we identify the elements of the thematic layer stack, as I showed you previously, based on these information requirements. Step 3, we're looking at the scale ranges and spatial representations. GIS is very scale-centric, and for example, a census project may focus on a small region like a city block, while an atmospheric one may include data sets of the entire globe. For each of the layers, it's important and useful to specify the map use, the data source, the spatial representation. Are you going to be using points, lines, polygons, or rasters? As well as the symbology and annotation. Then in step 4, we group these layers into data sets. These can be organized thematically or by geographic location. Next, in the logical design phase, we define the tables and their attributes, their subtypes and relationships, and we do this early on in the logical design. This helps us to, in step 6, identify where we want to make use of some of the GIS capabilities that allow us to control spatial properties like those implemented in networks or topologies. We include these in step 7 in the logical model when we propose a geodatabase design. Once we've designed the model to our satisfaction, we often need to test it and refine it. Here's where we will implement what we call the 3 Ps in the physical design stage: the pilot, prototype, and production database. It's important to remember that this is usually the iterative part of the process. Don't expect to get it right the first time. Usually some workflow patterns emerge at this point, and in step 9, we can preserve some of the normal day-to-day GIS functionality that we use on the database in an Arc Toolbox model builder environment. You can create a geoprocessing model to store GIS functions used on the features in the database, or to create the database elements themselves. The final step is documenting the design, and this is useful to communicate the contents of the geodatabase and its implementation. Often when managers get together with technical leads around a poster or other graphic representation of the database, it can help to explain and describe how the architecture and design of the data help to generate new information and decisions. These are the 10 steps that we have identified as useful guidelines to follow, and some of the things to keep in mind when going through the 3 phases of data modeling. While they're listed step by step here, it's important to remember that you will often learn things from one step that will cause you to go back to an earlier one and refine it or make changes. Now I'd like to show you a software demonstration in Arc Catalog using the ArcInfo or Editor license. I'm going to show you the use of case tools to create a database from a template that's stored as an XML file. I'll also show you how to set the spatial reference for the geodatabase and load that data into this empty geodatabase schema. So I'm going to go ahead and open up Arc Catalog, and here you'll see I have several things in the catalog interface. One is an Arc Parcels sample database. This contains a feature data set, a number of tables and relationship classes. And within these, there are attribute and feature data. Below this is the parcel schema. You'll notice it looks the same. However, inside of this database, there is no data. If I preview some of these feature classes within the feature data set called land, you'll notice that there is no geographic features, and the tables have only the feature field definitions and not the attribute data populated. So I'll show you for a few of these the empty schema, and then in addition we also have table structures and relationship classes defined. This empty schema is the topic of one of our design processes of loading data into this empty schema. So I'll show you this with some of the other data that we have here: a site addresses coverage, and the parcels XML document. Now this XML document is one of the items that we can download from the data model's website, which I'll show you in a moment. Using this XML document, we can take the template design for this data model and create a physical geodatabase from it. Then we can load data, for instance this tax parcel shapefile data, into the empty schema. I'll show you this process. It's important to note that we do need to have this uml.dtd file in the same folder, and you can download this from the website at the data model's website, and we'll show you another location where you can download this uml.dtd. But first let me show you how you actually use these templates in Arc Catalog. We'll need to add a new tool to Arc Catalog called the Schema Wizard. I'm going to the Tools pull-down menu and clicking the Customize dialog box. Once this dialog box is up, I can click the Commands tab, and in the categories you'll see there's a Case Tools. Clicking the Case Tools allows me to access the Schema Wizard tool, which I can then click on and drag and drop and place it on my toolbar in Arc Catalog. I'll go ahead and close the Customize dialog box, and you'll notice the Schema Wizard is grayed out. It remains grayed out until I highlight a geodatabase or create a new geodatabase into which I'm going to load this parcels schema. I'll go ahead and create this new geodatabase and call it parcels. And into this empty geodatabase, I'm going to load the parcels XML template and create an empty schema. I have the option in the Schema Wizard to access models that are stored as an XMI file. The XMI is actually a format, and the file type is called XML. So I'm going to go ahead and browse to this parcels XML document. And once I browse to the parcels XML document, you'll notice that the XML file is actually a document that's available from the data model's website as well. So here I've found the parcels XML document. I'm going to go ahead and open this and add it to the Schema Wizard. And now it's going to go to that document, the template model, and it's asking me if I'd like to use default values or use values from a previous run. This is referring to the spatial reference data information, which I've used from a previous run. I'm going to go ahead and select the default values. And clicking on Next, it's now going to the parcels XML document, parsing through it, and using it to create a physical geodatabase. I have the option here to turn off or on featured datasets within this schema. And you'll notice below the feature class data, we also have all the tables and relationship classes. At the feature dataset level, I can also go in and click on the properties to set the spatial reference for that feature dataset. This is similar to the way that it is handled with shapefiles or coverages. I can click on the Edit button and either select from coordinate systems that are predefined and stored as either geographic or projected, or I can import the spatial reference from an existing data set. I'll go ahead and browse to the shapefile data, and using the shapefile spatial reference information, I can populate the feature data set. You'll notice it's been populated with NAD83 state plane projection information. I also have the X and Y domain, the min and max X and Y values, and any other Z or M domains defined in the spatial reference. I'll go ahead and OK through this, and next, to finish this operation, I have a summary here showing all the domains and feature classes that have been created, and it's asking if I'd like to see the log file. I'm going to go ahead and say no and go ahead and show you what's in this parcels database. You'll see now that it's got the full schema, the land feature dataset, and all of the data schema for the feature classes. Now the schema is the empty containers for the data. So let's go ahead and load these with some other existing data that we have. We'll start with the site addresses. I'd like to load my coverage data into this site addresses feature class. So I'm going to right click, go to load, and load data. Here I can browse to the site addresses feature class, coverage, and select the point feature class and add that to the simple data loader tool. I can select to either load all the features into a subtype or leave it as the default. I don't want to load all features into a subtype. And here I have the option to match the source field or the coverage field data with the target field, this new feature class in the geodatabase. I'm going to go ahead and match these so that my street number suffix stream is a string value is also going to be matching the coverage data. Now I'll next, and I'll go ahead and select to load all of the source data and finish this operation. And you'll notice that we now have the points loaded into our catalog, and in addition we have the table values represented here as well. We can do the same thing with the shapefile data. I'll go ahead and put this back into Contents view, and using the tax parcel feature class, I'm right-clicking and going to Load Data, and I'll go ahead and browse to the shapefile data for tax parcels. I'm going to go ahead and add this to the simple data loader, and next, through this dialog, match the source field for the different field descriptors, making sure that the field types match, and completing this operation to show that we can load both shapefile and coverage data into the database. You'll notice it's not it's updating after refreshing at the database level. All the data with the tax parcels shapefile has been now loaded into the feature class of the geodatabase. And this is both the feature data and the table data, the attributes. So, what we've gone over here is a general description of the Data Models Initiative at ESRI. We talked about the modeling process and the layer stack, the cycling phases of the conceptual, logical, and physical design, and I showed you in ArcCatalog, using the ArcInfo and Editor license, the use of case tools to create a database from a template that's stored as an XML file. We set the spatial reference for the geodatabase using a shapefile, and then loaded the data from the shapefile and coverage into this empty geodatabase schema. Now I'd like to turn it over to Brenda to answer some of the questions that have been coming in.
Thanks, Joe. We have a couple of questions. Jessica from Upper Marlborough asks, can you create your own XML file instead of downloading it from the Data Models website? Of course you can. New functionality in ArcGIS 9. You can right-click on the geodatabase and use the Export to XML option, or through the Geoprocessing framework, Arc Toolbox, you can get to that as well. You can use case tools to generate XML files, and Joe's going to show you that in the next part of this lecture. Christine from St. Peter says, is there a point when you will no longer be able to refine the design of your geodatabase? Absolutely not. You will always be able to refine the design of your database. Your geodatabase, Christine, is a living document, a living process. Yesterday, I couldn't store raster or design raster in my personal geodatabase, and today I can. A year ago, I couldn't build topologies or spatial relationships between my layers, and today I can. So as technology continues, yesterday I captured my control points from paper documents, and today I'm using Trimble technology and capturing GPS. So as technology constantly changes, so will your GIS applications, and so will the design of your geodatabase. So you'll always be able to refine that thing. Tom asks, he's from Little Rock, and he asks, can't I simply create the geodatabase schema by creating new feature classes and tables in ArcCatalog? Absolutely. ArcCatalog is anything you can design in the geodatabase, you can design it through ArcCatalog. There's some other ways of designing schema, and Joe's going to go through that in the next section. And one last question. Joseph from Springfield says, if I download a data model, create the schema, and then use Geodatabase Designer tool on it, can I make a poster similar to some of the PDFs or GIF files that are on the website? And Joe actually is our expert here at ESRI. There's a lot that goes into using the diagrammer, and the process the effort that you put into it. He uses watermarks. He does an awful lot of designing on those things. So don't expect it to happen in just a couple of hours. Expect it to take days, Joseph. And then yes, of course, you can create models that are similar to the ones that Joe creates on the website. Joe, do you want to add to that?
Sure. I'm not the only one creating those, but there are several people at ESRI, and more importantly, they're the result of collaborative work that we do with people outside of ESRI to get some of the best ideas and content that's important for different industries and include those in the database design. So thanks for your questions, and thanks, Brenda. We'll go ahead and continue with the second section of this seminar, which will focus on the actual use of the design templates, how they're implemented in the GIS to create a geodatabase. There are over 25 data models that ESRI has collaborated with industry leaders and different focus groups to create. Now, each of these models can be used to create a geodatabase that already has a lot of the elements defined and can be used to get a jump start on your GIS project. Different parts of the models can also be combined to serve applications that need to build on the elements of multiple models. For example, elements of a transportation data model can be combined with the parts of the atmospheric data model to answer geographic questions related to rainfall and traffic. These are only a sampling of some of the data models. There are actually a set of many others that are hosted at the Support Center website, where you can find a description of the industry model, links to different interest groups and forums, key points of contact as well. In addition, at the website you'll find available for download all of the case studies and design template documents that result from these collaborations that ESRI has with external groups to create these models. Let me go ahead and browse out to the ESRI website and show you where the Data Models Support Center website is. You click on the Support tab and the ESRI Support Center to open up the ESRI Support Center website. You'll notice above the analyst's picture there is a Data Models link that you can click that URL to get to the Data Models website. Here you'll see there's a general description of the Data Models initiative at ESRI. There's a Data Models Tips and Tricks page, and this has a number of useful documents that are descriptions of some of the tools that are used in data modeling, including the Extract Data Wizard, the repository to the geodatabase, and spatial reference in the geodatabase. We can also see at the Data Models website a listing of all the different data models that we have current collaborations with, and the design templates and case studies that are available for download for each of these data models. Now you can go visit this website later and find some valuable things to download. A lot of these are the templates which can be used to create the schema of the geodatabase. Now we've used this word schema a lot. The word schema refers to the description of the data contained in a database. It's the structure of a database. Its tables, their names, their fields, the field data types, and so on. In the case of a geodatabase, the schema includes the tables, featured datasets, feature classes, subtypes, relationships, and more. Once the design of your geodatabase is planned, there are 4 ways to build schema. You can create schema with ArcCatalog, and ArcCatalog has context menu wizards to help you create everything this geodatabase can contain. For example, when I right-clicked and created a new geodatabase. You can also create schema by importing data. The process of importing tables, coverages, or shapefiles creates the schema for the corresponding geodatabase, tables, or feature classes. Data import wizards allow you to modify the schema as part of the import process. Importing data creates schema only for a table or feature class. You can use the ArcGIS wizards to create other elements such as relationship classes or geometric networks and topologies. We can also create schema with case tools. You can choose to define the content and structure of a geodatabase using third-party case tools like Microsoft Visio or Rational Rows. These tools create a visual UML model diagram of the database, which ArcGIS Schema Wizard uses to generate corresponding geodatabase elements. Case tools cannot create certain types of geodatabase elements, though, like annotation, topology rules, and raster datasets. Keep that in mind when using UML to create your database. You can add new tables or feature classes to the model template and then reapply the model to an existing geodatabase to create the new elements. You can also generate the schema of the geodatabase from the geoprocessing framework. In Arc Toolbox, under Data Management Tools, many different geoprocessing tools are available for you to create data structures and much of the geodatabase behavior. You can create feature data sets, feature classes, relationship classes, and subtypes, all within the Model Builder environment. Once you've created the schema, you can implement the database, create or remove existing relationship classes, and create other specialized features that can participate in topologies or networks. Finally, you can load data or populate the empty schema as I demonstrated. In this slide, we see part of a template model or UML diagram. The boxes represent feature classes, and the listing beneath them are the attribute or table definitions, and subtypes are represented by other boxes. There are lines connecting object classes or feature classes, and they're representing the inheritance of a feature or the attributes that carry down from one feature class or object class, which is a table, to the next. Lines represent the relationship classes, and their cardinality can be represented as well, one-to-many or one-to-one. The data model templates can be represented as analysis diagrams. They can also be used as a reference document. Some are created using UML and can be exported as a repository, or they can be exported as an XML format document, the XML file. This is a file type of the Extended Metadata Interchange, or XML format. These are specific elements of the data in a model that can be used to create a physical database or an empty schema. The elements that are not needed can be easily removed, or you can rename them to better fit your data and create a geodatabase that's tailored to the GIS work that you're doing. The Schema Wizard is the case tool we used and demonstrated in our catalog that's used to move the schema from an XML or a repository to a physical geodatabase. The first step before using this tool is to create an empty geodatabase, or to use an existing database as the starting point into which you will create or add new schema. You can think of schema as a skeleton of the database. It's the description of the feature classes, tables and their attributes, relationships, domains, and subtypes. Not all elements in the template are needed for each individual project. For example, you may start with a schema that has 10 different relationship classes defined. You may want to select 2 of these that are relevant to your work and delete the rest. Geoprocessing models can be used to create schema as well, and they're most commonly used to store workflow processes. Once you have a data model design that you're happy with, the workflow or GIS functionality that you employ on the data can be preserved in this graphic environment and more easily shared with others. Notice the toolbox that's storing the data the geoprocessing model, can be represented and appended to the geodatabase itself. The Geodatabase Diagrammer can be used to document the geodatabase once it's complete. The resulting output from this tool is a set of graphic elements representing the content of the database. These can be then used to diagram the database or create a poster. It's important to note that the difference between this model diagram is that it cannot be used to automatically create a data model. It just represents one. The tool can be downloaded from the Arc Online developer samples and does require Visio to work. Let me show you an example of one of the model posters that is created using the Geodatabase Diagrammer. In this example, we can see an address data model. In the ArcGIS data model, we have several different feature classes, and I'll zoom into a smaller area here to show you some of these feature classes that are the blue boxes. The domains, in this case a coded value domain, represented by the red box, and the green boxes represent your relationship classes. These are some of the outputs created by the Geodatabase Diagrammer. You can then take these graphic elements and drag and drop them or import them into another drawing tool like Adobe Illustrator to create a poster or diagram. You need to then create these lines to reflect the relationship classes and the different elements of the poster. Let me go ahead and show you an example of using the Data Extract Wizard to create a new geodatabase with some different extents from parts of Schema. And if there's time, I'll also show you a demonstration of using two different models and merging them into one. I'll go ahead and open up ArcMap, and one of the first tools that I need to add to the ArcMap interface is the Extract Data Wizard. To do this, I'm opening the Tool drop-down menu and clicking on Customize. This opens a Customize dialog box, and in the Toolbars tab, you'll find the Disconnected Editing tool. Check this on, and the Disconnected Editing toolbar becomes active. You can then drag and drop this onto your ArcMap interface. You'll notice these tools are also grayed out until you add some feature class data. I'm going to go ahead and browse to my transportation data model, where I can find some of the data sets from Albany, New York here, and we'll go ahead and add the transportation feature data set. Now this will add both transportation data set, the feature class within it, as well as the alternate street tables and the relationship class. Now what we're looking at are the features, the street features of Albany, New York. Now let's say there was a Homeland Security data model that needed to focus only on a small region of this database. Say there was an incident that occurred and we needed to create a subset database of just these elements and quickly send that back and forth between Washington, D.C. and New York City. We can use the Extract Data Wizard to quickly create a new geodatabase from these features. The Extract Data Wizard offers you the ability to extract data from either the data or the schema only. I'm going to go ahead and use the default of data. It extracts the data to a new database that it creates called extract_output. Or you can also browse to an existing geodatabase, and it will extract this new feature class, and geodatabase components into a new geodatabase. I have the option to reuse the schema, and I'm going to select Showing Advanced Options. This will give me the ability, when I click Next, to change the spatial extent of the data that I'm extracting. I'm going to use the current display extent so that the new geodatabase represents only the data that I have in my zoom window. You can also choose the full extent of the data, or you can interactively select a following extent by entering in values into that interface. You also have the option here to include different feature classes or the relationship classes and related tables. I'm going to go ahead and include all the contents and extract the related data in order to extract the relationship class and the table as well. And when I click Next, I get to the final options, either no further action, to change the layers and tables to point to the extracted data, or I can save a copy of this map document, the MXD, to point to this newly extracted database. I'm going to go ahead and finish the operation, and as the extract data wizard works, it's creating a new geodatabase based on this new zoom extents that I've defined. Let's go ahead and have a look at that database. I'm going to open up the Demo2 folder, and in the Transportation directory, here we have the extract output database that we've just created. Within that, we have the Transportation dataset, the Street Segments feature class, the alternate streets name table, and the relationship class between these elements. If we take a look at that, Street Segments, we have a new database that includes only the relevant features for this extract. This can be useful if you need to take a subset of a geodatabase. It's also a useful tool if you need to create a new geodatabase with different extents. If you've ever received the out of bounds error when trying to add new data to a geodatabase that already has extents defined, this is the tool that will enable you to create a new geodatabase, change the spatial reference as you're doing it, and then be able to load new feature data. Now, this only works on the schema of the database if you're changing the spatial reference, so keep that in mind. You will need to reload the data into the database after using this tool. Now I'd like to show you creation of a new geodatabase using the elements of two different templates. So I showed you on the website where you can download some of the design templates, and I've gone to that website at the support center and downloaded the template for the Hydro schema, which looks like a geodatabase because it's a repository. It's all the tables representing the contents of this database. And then I've also downloaded the Marine schema, which is an XML document representing the geodatabase for the marine data model. I'm going to go ahead and create a new geodatabase, which is going to be comprised of these two different schemas, and so I'll call it Hydro Marine. I'm going to use the Schema Wizard and first point to the data that's been stored in this XML file and browse to the marine data model XML document. I'm going to add this marine schema XML to the Schema Wizard, and when I next, it's going to that XML document. I'm going to go ahead and use the default values, and from that create the new schema for the marine part of this data model. Now I may not want to use all of these feature classes, feature data sets, so I'll check off the ones that I'm not interested in and include all of these marine features. I'll go ahead and next through, view the summary of what the Schema Wizard is doing, and I'm going to opt not to see the log file. And now I'm going to go ahead and do the same thing for the hydro database. We've created the marine features within this data model, and now I'm going to go ahead and reuse the Schema Wizard, this time for models stored in a repository, and I'm going to go ahead and browse to the hydro schema and add that to the Schema Wizard. I'm going to click Next, and you'll see that it's pointing now to the repository for the hydro data model. It's an ArcInfo UML model. And now it's loading the objects from that repository into this new data model. I'm going to go ahead and use the default values, and there's an error there, but it's not going to interfere with completing this operation. I'm next going to click Next, and we'll see here that again we have the opportunity to choose from the hydro data model which elements are of interest to add. I'm just going to add this geometric network, the hydro junctions and edges, to this new database. So I'll check off these other feature data sets and click Next and finish this operation. Now let's have a look at the hydro marine data model that we've just created. It includes the schema for the marine features as well as the geometric networks for hydro junctions and edges. So using this approach, I could create a database that may capture the properties of a stream, maybe pollution flowing out into the ocean, and this could be a useful application of two different data models using the case tools and the Schema Wizard to create a new database from two different design templates. Now if I'd like to export this, say I'm really excited about this database and I want to send it to someone, I can right-click on it and export to an XML workspace document. Here I have the option to export either the data or the schema only and create a new output export XML document for this representing this database. I also have the option here to choose different feature classes and to select whichever feature data sets I'd like to include in this output. And the resulting export creates a new XML document which can then be sent to someone else, and they could use the Schema Wizard and recreate the same schema for a database that I've created using this tool. So these are some of the useful tools that can be used in working with the templates, both XML and repository templates in ArcGIS. I'm going to go ahead and minimize this for now and cancel this operation and return back to our presentation as we're running short on time. So in this section we've covered the data models that ESRI collaborates to create, some of the methodology that goes into project design, and the templates that we use and make available for download on the website, and we've shown you how to use them. We also talked about the geoprocessing models and Model Builder that also includes schema creation tools. We also showed the Geodatabase Diagrammer and demonstrated the use of the Extract Data Wizard to create a new geodatabase, the subset, with different extents from the parts of the schema of the other geodatabase. And we showed the merging of two different data models into one. Now I'd like to invite Brenda back over to answer some more questions. Brenda?
Thanks, Joe. Let's see. Josh from San Diego asks, if I have schema for a geodatabase in ArcGIS 8.3, can I use it to create a geodatabase in version 9? Easy to do, Josh, if it's a personal geodatabase. If you've got the ArcGIS 9 application, then any database that you created in 8.3, you'll easily be able to read the schema in 9. If it's an ArcSDE database, on the other hand, it actually involves importing it out of the 8.3 and into the 9. So it's a little more complicated if it's Enterprise or ArcSDE. Preston from Blue Springs asks, can any data modeling be done without the Schema Wizard or without ArcInfo? You can certainly do data modeling. Joe showed you. Model your data from existing coverages, from existing shapefiles, from CAD, from VPF. Any existing data that you already have, you can use that schema to generate schema in the geodatabase. Case tools are the other option. He showed you as well the geoprocessing framework using the model builder to do your data modeling with. So yes, there are other options available to you, Preston. Let's see. Vicky from Dallas asked, why did you have to create the new geodatabase before using the Schema Wizard? The Schema Wizard, Vicky, doesn't have the engine in it to create a geodatabase. The geodatabase has to be existing. The Schema Wizard will make changes to your existing schema or generate new schema inside of an existing database, but it doesn't have an engine in it to actually create the geodatabase. And I want to tell you as well, the Schema Wizard doesn't have to be executed against a personal geodatabase. If you've got a connection to ArcSDE to an enterprise database, you can right-click on that connection and use the Schema Wizard and browse to that connection when you're using the Schema Wizard. It doesn't have to be on the personal geodatabase. Tom from South Bend asked, if I don't specify a spatial reference information using the Schema Wizard, can I specify it later once the schema is built? Parts of your spatial reference can be changed later. The precision and the spatial extent cannot be changed. So you can change your projection and your coordinate system later, but once you've created that data layer, your precision and the extent are set for you.
And I'd like to add one other question and answer to Alice in the Oceanside. She's asking, do we have to use the XML file as the template? And where can we find this XML file? Well, Alice, yeah, you can use the XML file as a template, or you can use UML, a repository, as the template as well. You can create these in ArcCatalog by right-clicking and exporting from an existing database, or you can find the ones that we host on the ESRI website. Now, I pointed you to the ESRI website where we host the data model design templates and case studies. I'll go back here quickly and show you for an example. At the Support Center site, if you're interested in a parcels data model, and you go to the Land Parcels Data Model website, and you'll find that there's a brief description of the data model and who are some of the leads in this data model initiative. There's also a set of downloads. We've got the case studies and the design templates as well. Here you can find the design template files for the parcel database, parcel data model design templates, and available for download from this are the personal geodatabase, the XML, the GIF, and Visio designs. And hopefully if you click on this link, you'll be able to download those directly to your machine and begin working with the case tools. So thank you for your questions, and thanks, Brenda. And I'd like to point you to a few different areas for further information. We've got several different courses available at the ESRI Virtual Campus. One is the Using Case Tools. This is for ArcEditor and ArcInfo. We have the Creating, Editing, and Managing Geodatabases for ArcGIS 9, and the Creating and Editing Geodatabase Features, also available on the ESRI Virtual Campus. We also have ESRI instructor-led training courses, including Modeling Geodatabases using Case Tools, the Geodatabase Design Concepts course, and Building Geodatabases 1 and 2. You may find some of these courses available in the Learning Pathways program that was described at the beginning of this live train seminar. There are also ESRI Press books available, Modeling Our World and Designing Geodatabases are two really good books related to data model design. And there's the product book, Building a Geodatabase. And it looks like we're about out of time, so on behalf of ESRI, I'd like to thank you all for attending.